Today in chemistry revision class we will revise the chapter atoms and molecules, but we will revise only important topics which are important from your examination purpose, right? Students, what is matter? Let us define matter as: matter is made up of small particles which may be atoms or molecules. As different kind of matter contains different type of atoms or molecules which have different properties. Hence, different kind of matter have different properties. We will discuss now law of chemical combination. The reaction of two or more substances to give out the product is governed by a certain law. These laws are known as laws of chemical combination. On the basis of much experimentation carried by Antony L. Lavoisier and Joseph L. Proust, the composition of matter and chemical reactions, these laws of chemical combination are established. The laws of chemical combinations are: the first law of chemical combination says, or it is known as law of conservation of mass or matter. Second law of chemical combination is law of constant proportions. Students, we will discuss the first law, that is the law of conservation of mass. This law deals with the masses of reactants and products involved in chemical reaction. This law was discovered by Antony L. Lavoisier. According to this law, mass can neither be created nor can it be destroyed in a chemical reaction. In other words, in a chemical reaction, the total mass of the reactants is equal to the total mass of products. Second law is the law of constant proportions or the law of constant composition. This law deals with the composition of elements present in a given compound. This law was discovered in 1799 by the French chemist Joseph L. Proust. According to this law, a pure chemical compound always contains the same elements combined together in the same fixed proportion by mass. In other words, in a chemical substance, the elements are always present in definite proportion by mass. Students, we are going to discuss the Dalton's atomic theory. After the two laws of chemical combination were discovered, the next problem faced by the scientists was to give appropriate explanation of these laws. This led a British chemist, John Dalton, who started his career as a school teacher in England and became a great scientist, to put forward the basic theory about the nature of matter in 1808. This theory is known as Dalton's atomic theory. This theory is based on the concept of divisibility of matter, which was proposed by ancient philosophers. The postulates of Dalton's atomic theory are: number one, all matter is made up of very tiny particles called atoms. That is, same name that was used for the smallest indivisible particles by Greek philosophers. Second postulate is atoms are indivisible particles which can neither be created nor destroyed in a chemical reaction. Third postulate says atoms of given element are identical in all respects, that is size, shape, mass and chemical properties. Fourth postulate says atoms of different elements have different sizes, masses and chemical properties. Atoms of the same or different elements combine together to form molecules or compounds. Sixth postulate says during chemical combination, atoms of different elements combine in the ratio of small whole numbers to form compounds. Seventh says the relative number and kinds of atoms are constant in a given compound. Eighth one, atoms of two different elements may combine in different ratios to form monoxide and carbon dioxide, in which the ratios of the combining atoms carbon and oxygen are 1:1 in carbon monoxide and 1:2 in carbon dioxide respectively. Next postulate says atom is the smallest particle which takes place in a chemical reaction, that is whole atoms rather than fractions of atoms take part in a chemical reaction. Students, what is an atom? An atom may be defined as the smallest particle of an element which may or may not be capable of free existence. However, it is the smallest particle that takes part in a chemical reaction. Discuss atomic mass. The atomic mass of an element is the relative mass of its atoms as compared to the mass of an atom of carbon 12 isotope taken as 12 units. Therefore, 1/12 of the mass of an atom of carbon 12 isotope represents 1 unit of mass on the atomic scale. This is called 1 atomic mass unit, or written as AMU. According to the latest IUPAC recommendations, it is now written as U, small u, which stands for unified mass. Alright. Students, now we will discuss the molecule. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. In other words, a molecule is the smallest particle of an element or a compound which can exist freely under ordinary conditions and shows all the properties of that substance. Now, molecules of an element. The molecule of an element contains 1, 2 or more atoms of the same element chemically bounded together in the free state. Students, molecules of a compound contain 2 or more atoms of different elements bounded together in a definite proportion by mass, which can exist freely. Discuss about molecular mass. Molecular mass of a substance may be element or compound is the average relative mass of its molecules as compared to that of an atom of carbon 12 isotope taken as 12. In other words, molecular mass of a substance, it may be element or a compound, represents the number of times the molecule of that substance is heavier than 1 by 12th of the mass of an atom of carbon 12 isotope. Now calculation of molecular mass. I will explain it to you by giving an example. We know that the molecules are made up of two or more atoms of the same or different elements, and each atom has a definite atomic mass. So, molecular mass of a molecule of a substance is equal to the sum of atomic masses of all the atoms present in one molecule of the substance. Let us take an example. A molecule of hydrogen has the formula H2. It consists of two atoms of hydrogen. So the molecular mass of hydrogen is equal to 2 into atomic mass of hydrogen. It is equal to 2 into 1.0 U. The atomic mass of an atom of hydrogen is 1 U. Therefore, molecular mass of a hydrogen molecule, that is H2, is equal to 2 into atomic mass of hydrogen atom. It will be equal to 2U. Let's see some more examples. Discuss about the valency. The valency of element is defined as the combining capacity of the element. It is equal to the number of hydrogen atoms or number of chlorine atoms or double the number of oxygen atoms with which one atom of the element combines. Here in this table you can see the valencies of some common non-metal elements. Now valency of an ion, it is defined as the units of negative or positive charge present on the ion. Now in this table I am going to show you some common cations or positive ions, and in another table there are some common anions or negative ions. Students, let us discuss the rules for writing the chemical formula. First one is, in case of a simple molecular compounds, that is those compounds which are made up of only two elements, the symbols of two elements are written side by side and their respective valencies are written below their symbols. Second rule is, the valencies or charges on the ion in the ionic compounds must be balanced. Third rule is, in case of simple ionic compounds, that is compounds made up of monoatomic ions, the symbol or name of the metal atom forming the cation is written first, followed by the symbol or name of the non-metal atom forming the anion, and their respective valencies are written below their symbols. For example, calcium oxide CaO, sodium chloride NaCl, iron sulfide FeS, copper oxide CuO, etc. where oxygen, chlorine, sulfur are non-metals and are written on the right, whereas calcium, sodium, iron and copper are metals and are written on the left. In case of ionic compounds formed with polyatomic ions, the formula of the polyatomic ion is written in brackets and the valencies are written below as in the above cases. Next is, in any of the above cases, if there is a common factor between the valencies of the cation and the anion, the valencies are divided by the common factor. In the end, we apply crisscross, that is crossover of the valencies or the charges so that they appear on the lower right hand side of the symbols. However, one appearing on the lower right hand side of the symbol is omitted. Similarly, positive and negative signs of the charges of the ions are omitted. For one appearing on the lower right hand side of a polyatomic ion, the brackets of the polyatomic ion are also omitted. Now I am going to show you chemical formula of simple molecular compounds. Students, we will do an example to calculate the formula unit mass. So the question is, calculate the formula unit mass of ZNO, Na2O, K2CO3. It is given that the atomic mass of Zn is 65U, sodium, that is Na, is 23U, potassium, that is K, is 39U, carbon, that is C, is 12U, oxygen, O, is 16U, sulfur, S, is 32U.